All right, guys, welcome to statistics for April 17th. We're going to be talking about something called confidence intervals today. Now, a confidence interval is something that we've kind of been talking about the last few days without ever actually formally putting a name to it. And you're going to see how it comes up today. So, we're going to look at an example for a data set, and then we're going to work a little bit with the confidence intervals, margins of errors, all that with it. So if you look at number 19, it says among, and this is on the second page of your packet, by the way, among 1,815 randomly selected high school students surveyed by the CDC, 417 said they were current smokers. Okay, so here's the data set. What we can do is we can use this data and say, okay, 417, if my pen would work, which it doesn't, so let me grab a new one of those. But we have 417 said that they do out of 1,815, right? So this is how many smoked over how many were surveyed. So that's going to give us a proportion of about 23%, and I'm just going to round that to the tenths. So that is a proportion of 0.23 or 23%. Now, what we can do with that proportion is then find the standard deviation. This is just what we've been doing the last few days. You guys already know this. To find that standard deviation, 0.23 times the opposite of that, 1 minus that number, so 0.77, over the number of trials, or how many students were asked, 1,815. We can plug this into our calculator. 0.23 times 0.77 divided by 1815, and we get 0.0098. So what I'm going to do is I'm going to round that to 0.01. So the standard deviation, or the standard error, or the sampling error, is 0.01. Okay. Now what we've been saying the last couple of days is that 23% of people smoke with a margin of error of 0.01, or a margin of error of 1%. Now that would mean that 22 to 24% of people smoke, right? In all actuality. If we include this margin of error, that means that between 22 and 24% of people smoke. But I want you to think about this for a second. We have this standard deviation, right? That's where we're getting our margin of error. If we go one standard deviation below and one standard deviation above the average or the mean on a traditional normal distribution of data, how much percent of data is in there? You may be thinking, correctly, hopefully, that 68% of data is within one standard deviation. I'm going to write that down. 68% of data is within one standard deviation. What that means for what we call a confidence interval is that if we only consider our margin of error to be a single standard deviation, one below or one above, then we are only 68% confident that that range is where the actual true mean really is. So by going out one standard deviation on either side of what we found in our data set, then we are saying we're 68% confident, or we have a 68% confidence interval. Now 68 is good, that's better than half, but it's not great. Now you may be thinking, if we go out 2 standard deviations, there's a greater portion of data included there, right? Think about this. How much data is within 2 standard deviations of a mean? That's right. 95%. 95% of data is within 2 standard deviations. So we would be able to make a 95% confidence interval. And this is the confidence interval that the vast majority of, serious, reputable research uses, is a 95% confidence interval, going out 2 standard deviations above and below with that margin of error. Now that's going to make our margin of error a little bit larger. It makes us seem a little less sure, but we're much more confident that the real actual mean is between those numbers. So what we would do with this is we would say 23% of people in our research we found smoke with the standard deviation of 1%. So below we would go 2 down to 21%, and we would go 2 above to 25%. So what happens is by going out 2, we create a 95% confidence interval. When we only went out 1, we were at a 68% confidence interval. So this is the big difference. The more specific you try to be when you're trying to make these generalizations to what actually we see in the world, what's the actual percent of people who are smoking according to this example, right? The more specific we try to be, the less confident we are that we're right. So if we try to be real specific here, between 22 and 24, we can say, well, we're 68% sure. But if we let ourselves go out 1 more standard deviation, make our margin of error just a little bit larger, then we are 95% confident now that the real, true number, worldwide or nationwide, whatever our study is about, is between those 2 percentages. We're going to do this with one other example. We're going to take a look at number 20. Number 20 says, Rutgers University surveyed 4,500 randomly selected high school students nationwide. 3,329 of these students admitted they had cheated on a test at least once. We're going to make some confidence intervals here. So we have 3,329 students out of the 4,500 surveyed admitted to cheating. I'm going to type this into the calculator off screen here. But we get a proportion of 74%. So 74% of students admitted to cheating at some point. Now, we can find our standard deviation by taking the proportion that we found times 1 minus that proportion, so 0.26, and dividing it by the number of people surveyed, 4,500. I'm going to find that real quick. And there we get 0.006. Or about 0.6% is what we get. So what we want to do with this, because our de facto way of working with confidence intervals is going to be creating a 95% confidence interval. That's going to be our go-to. We could make the 68, but we don't want to do that because the statistically accurate, responsible thing to do is to make the 95% confidence interval. So what we're going to do is we're going to take the mean that we found. We are going to subtract this number twice because, again, 95% of data means within 2 standard deviations or 2 standard errors in this case. So we are going to subtract this number twice. So we're going to subtract 1.2 from that number, and we would get 72.8%. We are going to add 1.2 to that number, get 75.2%. and we can say our 95% confidence interval is that between 72.8% and 75.2% of all high school students have cheated at some point in time. So again, I really just want to hit home the reason that we're doing this, the reason we have to make this range, is because while this may be the data that we found, that was only surveying 4,500 students at a single, it said Rutgers conducted this. I don't know. I think they did it nationwide. Yeah, they selected them nationwide. So we chose just 4,500 students nationwide, right? But as great of a number as that is, it's possible that we got a number that's just a little skewed this way or that way. But by including that margin of error, those two standard deviations on either side, then we are expanding that number a little bit to where we can confidently say the nationwide, the mean for our entire population, for everyone in the United States, is between these two numbers. So it kind of takes out, the specificness of what we found and adds in some ability to generalize, saying that our numbers aren't necessarily 100% representative of the whole world or the whole U.S. So what I would like you guys to try out is number 18 here. Let me move things around to get this on screen. So number 18, we have 4 scenarios, okay? Now what I want us to do is not worry so much about what exactly it says in the problem, right? It says explain what P and P hat represent, yada, yada, yada. Now, don't worry about all that. Here's what I want you to do. I want you on A all the way through D, all of these included, is to find the true proportion, which is in fact P. Find the true proportion. And then find a 95% confidence interval for the data. So find the true proportion and find a 95% confidence interval for the data on all 4 of these parts to number 18. That's what I want you guys to try out. If you have any questions on it, shoot me an email. I'll be more than happy to help out. Otherwise, Monday we'll talk about any of them that you may have had trouble with. Otherwise, we'll keep this moving. We'll keep on going into some future concepts and lessons. See you guys then.